So what is the rule for a power of a product? So let's talk about this. This is a power of a product because there's multiple things being multiplied in here, more than one thing. It's not just an x. There's 4 pieces being multiplied, and it has a power on the outside. Again, multiple things being multiplied inside the parentheses and a exponent on the outside. So what is the rule for this? Let's talk about what this means. So what this is saying is that we have negative 5x, y, z to the third listed out 4 times, right? So z is listed out 3 times. So if I do that, that's negative 5, x, y, z, z, z to the 4th power. Do you guys agree with that? I'm going to show you what, we're going to figure out what the rule is together, rather than just me telling you the rule. So I'm going to do that 4 times, because that's what the exponent on the outside says. Put lines through my z's so you don't think they're 2's. So go ahead and list that out 4 times.
Might you have everybody here today and nobody tardy?
I do not. Yeah, I know. I know, it's sad, I know.
Who is in here?
Our 2 sophomores.
You look at those. I mean, we just took them out of the oven. They're still warm and chocolate milk is cold. We'll try again.
Sorry, guys. All right, so we have those listed out. So what are we going to do with the negative 5, the negative 5, the negative 5, and the negative 5? What do you think we're going to do with those? What are you going to do with those? What? I know it's killer, guys. I'm sorry. It's not my fault. So, negative 5, negative 5, negative 5, and negative 5. What are we going to do with that? We're going to continue to multiply them, right? So negative 5 times negative 5 times negative 5 times negative 5. So we're going to multiply those 4 times. So how many x's do I have? Total. We can count out our x's. How many x's do I have? 4, so that's x to the 4th. How many y's do I have? Good, I have 4 if I count them. Then how many z's? Good. So, what is negative 5 times negative 5 times negative 5 times negative 5? So I know it's 25 times 25. Is it 625? Is that what it is? So 625, x to the 4th, y to the 4th, z to the 12th. All right, so we're going to do one more, and we're going to figure out what this rule is that we're using here. Okay. That 4 that's on the outside of the parentheses there, can we distribute it in? Think about PEMDAS. What comes first, multiplication or exponents? So can you distribute it in? No, exponents come first, so do not do that. The 4 on the outside, does that 3 pertain to the 4 on the outside? Do we list 4 out 3 times? No, it's not trapped inside of that, parentheses, so we don't do that. So I have 4, and then I have negative 3, a 4 times, and b 5 times, all to the 3rd power. So then I'm going to list that out again. The 4 does not get listed out more than once. Oh no. I put too many B's on one of these. It should only be 5. Went a little bit B crazy on that one. Okay, so we're good there. Sorry, it looks so terrible. Couldn't fit it all. So, what are we going to do with the numbers? What are we going to do with those integer numbers? What will we do with those? Just multiply them. So we'll do 4 times negative 3 times negative 3 times negative 3. How many A's do I have total? How many do I have? 12. We have 4 plus 4 plus 4, which is 12. And then how many B's do I have? 15. So I have negative 12 times negative 3, which is positive 36. Positive 36 times negative 3 is, what is it? Negative 108. So I have negative 108, A to the 12th, B to the 5th. Okay, so what do you think the rule is? Or Katie, do you have... Yes, I lost the 1 on it. Thank you. What do you guys think the rule is before we move on? What is the rule? What are you going to do? Look at what we got here. Think about what this is. For this one here, we got 625 for the number, which is not what that is there. We got x to the 4th, y to the 4th, z to the 12th. How did that happen? What did we do? Mackenzie? What'd you say? What'd you say? You multiplied the exponents. Did we multiply negative 4 times 5, though? What did we do to get 625? Hannah? So how would you write that? What's another way of saying that? That's not incorrect. What's another way of saying that? Mackenzie? Yeah, so all you're doing is you're giving the exponent to everything in here, and when it's an exponent to an exponent, we know that we multiply. So really what we did here is we did negative 5 to the 4th power, x to the 4th power, y to the 4th power, and then z to the 3rd to the 4th power. So we gave that 4 to everything. So if you type in, you always need to put parentheses around the integer numbers. Do not forget the parentheses. So if you go to type it in your calculator, you need the parentheses as well. So if you do parenthesis, negative 5, parenthesis to the 4th power, it will give you 625. X, it has a 1 on it. 1 times 4 is 4. Y has a 1 on it. 1 times 4 is 4. And then 3 times 4 is 12. So do you still get the same thing? So your rule there is that the exponent goes to every piece, including the integer number. The integer number is not being multiplied because it's not an exponent, okay? So remember, integer numbers, exponents, two different things. I know this isn't mathematically correct, but big number and small number, two different things. The big number, that integer, is the one you're going to do the same way you always have. So you're going to do that as an, like listing it out 4 times, or you can just type it into your calculator correctly as well. So go ahead to the next page when you're ready. All right, so it says the product of a power rule, which is what we just talked about, means you give the variable on the outside to, or the exponent on the outside to both pieces, and you multiply them together, right? Isn't that what we just said? So here are some examples. Help me out with these examples here. So Sarah, help me out with the first one. Yes, and then? Yeah, there's a 1 on that x. Don't forget the 1. So, bless you. W is to what power, Sarah?
7.
And x is to what power?
7.
And you are done. Kaylin. Number 2. What do we do with that negative out front?
Don't you not distribute yet? Because that would be the
Yeah, we can't distribute it, so what are we going to do with it? It's going to be something we do at the end. What are we going to do at the end?
add it to the negative, make the 2 a negative.
Yeah, we're going to multiply the final solution by negative 1. This just means multiply your final solution by negative 1. Okay, Kaylin. So how is this going to look after you write that down? How is this going to look when we go to simplify it? not, okay, so part of that was right. The negative's going to stay on the outside. What does the 2 also need? The 2 also needs that 4, doesn't it? Because didn't we in that very first example do -5 times -5 times -5 times -5? So isn't that saying 2 times 2 times 2 times 2 there with that 4? Do you understand what I'm saying? Are you sure? So this is really 2 to the 4th power, right? You got the other ones right. So you did b to the 8th to the 4th, and like you said, you multiply those. And then you have c to the 3rd to the 4th power, right? So that negative just stays out there to multiply at the end. What's 2 to the 4th power? 2 times 2 is 4. 4 times 2 is 8, so it's 16. Very good. Then we do b, 8 times 4. C, 3 times 4. I know I'm showing a lot of work. You don't have to show all this work on your homework. And then we get -16, b to the 32nd, c to the 12th. I'm showing the work for you guys, so when you go back and use your notes, you guys don't just assume, you don't just have an answer there. If you just have an answer there, it's going to make no sense if you don't remember what we did in class today. And this is first hour, and you have 6 more classes after this, so it's going to be very confusing for some of you. All right. Jill, help me with number 3.
It would be, in parentheses, would be the negative, and then would you multiply the 5 to the exponent?
Like -5 times 2 or -5 times 3?
Like -5 times 3.
So have we been doing that with these ones? So look at this one here. Did we do 2 times 4 here? Did we?
Then you did 2 to the 4.
Which is 2 times 2 times 2 times 2, right? So are you going to do -5 times 3?
No, you're going to do -5 to the 3.
There you go. Which means you're listing out -5 how many times? There you go. Okay. Good question. Very good question. Then what?
And you're going to use the 3 and multiply the 3 by everything that's in parentheses.
Not everything that's in parentheses. What are you actually multiplying the 3 by? 3 and the what by? The exponent. You're multiplying 3 to all the exponents. So it's x to the 2nd to the 3rd, and you will multiply those. Y to the 9th to the 3rd. So again, if you're using your calculators to type this -5 to the 3rd power in, make sure you're using parentheses. So you need to do parenthesis -5, parenthesis raised to the 3rd power using that caret button that we talked about a little bit ago. So we get that there, and that should be -125, right? Because -5 times -5 is positive 25. 25 times another -5 is a -125. So, Jill, what do I get then with the x's? X to what power?
6.
Yeah, because you're multiplying. So you did 2 times 3, and then what would your power be on y?
E7.
Very good. All right, guys. What questions do you have before we do that last one on this page, before we move on? I'm going to do one more on this page. How are we doing? Am I confusing any of you? Spencer, are you okay? Okay, just making sure. Heads down. Just want to make sure here. Anybody else? Like, anybody super confused? It's okay to be super confused. Just let me know, because I don't want to be confusing you. That's not my job. My job is not to confuse you, but, sometimes things don't go that way. All right, so how would I do, Avery, how would I do number 4?
You do the exponent 4 to -3, and then you multiply 10 to the power, you multiply the 7 by the 4, and then n to the 10th power, and you multiply the 5 by 10.
Good. What do I do with that 2?
You don't use it yet, you use it after.
So you'll multiply your final solution by 2. So I'm just going to drop that down here. Okay. So I get 2 times what? What's negative 3 to the 4th power? Avery. What's negative 3 to the 4th power?
Negative 80.
Be careful. Negative and a negative is a positive 9.
Wait, negative 3.
81 is fine. It's your negative. Because negative 3 times negative 3 is positive 9. 9 times negative 3 is negative 27. And then negative 27 times negative 3. So you have 2 negatives there. It makes it a positive. Yeah. So notice she did not tell me negative 12, did she? You're listing out negative 3 4 times. So that's negative 3 times negative 3 times negative 3 times negative 3. Okay, M is raised to what power? Avery's still talking to you.
Oh.
And what is N raised to? Okay, and then what do we still have to do? Multiply 81 by 2, and I get 162, M to the 28th, N to the 20th. All right, look at that page before we do power of a quotient. Yes, Jill.
So, when you do your first step, you use the exponent to solve everything in the, or you use it to multiply exponents, and then you use whatever's on the outside to wait till you finish.
Yeah, because of order of operations. So exponents, PEMD, exponents comes first, and that 2 out front is multiplication. So you have to get all the exponents simplified first, and then do multiplication. Does that make sense?
Yeah.
Anybody else? All right, so let's look at another rule then. What is the rule for a power of a quotient? So again, bless you, we're going to list this out. So I have 2xx over 5 to the 5th power, which means I list that out 5 times. Remember, when you're doing fractions, you multiply numerators together, which is the top, and you multiply denominators together, which is the bottom. Okay? So just remember that. All right. So on top, we have 2 times 2 times 2 times 2 times 2. You're not adding them together. That's multiplication. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Good. 16 times 2 is? So we have 32. How many x's do we have on top? 10. Good. Okay. Then on the bottom, in the denominator, we have 5 times 5, which is 25. Times 5, which is 125. Times 5, which is 625, times 5, which is, I don't know after that. 3,125? Okay, look at this. Do you think this is the final solution? Can you simplify 32 in 3,125? Okay, let's go back to the original. Could you have simplified 2 and 5? No. So from the beginning, you can't simplify. If you can simplify, do it at the beginning, or else it's going to get these huge numbers that you're going to have to try to simplify later. So since you couldn't simplify them here, you're not going to be able to simplify them here. Does that make sense to you guys? Okay, so that's the first one. So let's look at the second one and see if we can figure out the rule. And then that's to the 3rd power. So that means we're going to list that out 3 times. Again, if you forget the rule, you should list it out. I know that is more work, but when it comes to your grade, you might want to actually get it correct. And even if it's just doing it once on one problem to remember stuff. Did I do something wrong here? And that's what I would do at this point here. Very good. Negative 3 and 6, what goes into both negative 3 and 6? 3. So this becomes negative 1, right? And what's on the bottom then? 2, yeah. Negative 3 divided by 3 is negative 1. 6 divided by 3 is 2, so that's how it is for all of them. You want to simplify before you multiply those together because it makes it way easier to do it with smaller numbers than bigger numbers. All right. So now that we have those simplified, I have negative 1 times negative 1 times negative 1. What is, Iris, what is negative 1 times negative 1 times negative 1? Negative 1. How many A's do I have on top, Iris? Then I have 2 times 2 times 2. What is that, Iris? 2 times 2 is 4. Then we still have to multiply that by another 2, which is... And then how many B's do you have? Can you simplify this A and B? No, they're not like bases. Do not start subtracting those. They are not like bases. Remember, you can only do that if they have like bases. So who thinks they know the rule for this one? Who thinks they know the rule for this one? What are we doing here? Very similar to the other one. What are we doing here? What is our rule? Jenny? You're still multiplying the exponents, so you're giving the 3 to the exponent says here. What else are you doing? There's one other thing you're doing with that 3 there. Aren't I giving it to the numbers as well? So look at this. This is negative 1. We change those, right? And this is 2. So if I do negative 1 to the 3rd power, a to the 4th to the 3rd, over 2 to the 3rd power, b to the 1st to the 3rd power. So do you see how I gave that exponent to everything, including the integer numbers, those coefficients in front? Negative 1 to the 1st power is saying negative 1 times negative 1 times negative 1, which is still negative 1. 4 times 3 is still 12, which is what we got. 2 times 2 times 2 is 8. And then I do 1 times 3, which is 3. Is that what we got while we listed it out? Is this the same answer that we got? Yeah. So all you're doing is very similarly to what we did on the product of a power rule. The quotient one is the same, okay? So questions there before we do some more examples. So let's just start getting through these examples. And then I'll get you guys your homework. All right. So help me out here. Carly, help me out with the first one. What am I going to do? What did I say you should always do first if you can? Simplify first if you can. You always have to check to simplify. Can we simplify anything first before we distribute that exponent in? Can you, Charlie? Huh? I see a z on the top and the z on the bottom. Can we simplify those?
Oh, yeah.
Yeah. So what do you do when it's a quotient? What do you do with the exponents? So we have x squared y z to the 10th minus 7 to the 3rd power, right? So that's x squared y z to the 3rd power. Does that make that a little bit easier for us? It comes into a product one, doesn't it? So what am I going to do here, Carly? Yeah, what's the exponent on y? 1. We have a little 1 here. So x squared times 3, y to the 1st times 3, and z to the 3rd times 3. So I get x to what power, Carly? Y to the 3rd, good, and z to the 3 times 3? It's not 3 to the 3rd, it's 3 times 3. There you go. Okay, questions there? Katie, help me with the next one. Can we simplify anything first? And that becomes what? Good. Can we simplify anything else? So what is the exponent on the denominator D? 1. So that's 3 minus 1, right? And then I still have the E on the bottom. So I get D to the second over 2E, all raised to the 4th power. So what do I do with that exponent now, Katie? Multiply it to what? Okay, what else? You have whatever you have to distribute it both numerator and denominator. So you have to also do stuff to the denominator. So what are we going to do with the 4 and the 2? Are we going to do 2 times 4, guys? No! It's a number. It's not an exponent. We've talked about this. We're going to do 2 to what? There we go. Come on, guys. We can do this. And then E is also being raised to the... You give it to everything there. So we have D squared to the 4th. 2 to the 4th. And then E to the 1st to the 4th. What do you do with an exponent to an exponent? Everyone, what do we do with an exponent to an exponent? Okay, so I have D to the 2nd times 4. D to the 4th means 2 times 2 times 2 times 2 times 2. I think I said too many, sorry. Then I have E to the 1st times 4. Know what that means. It does not mean 2 times 4. So you get D to the 8th over 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. E to the 4th. Can I simplify D to the 8th and E to the 4th? Are they like parts? No, they are not. So that stays there. You're getting confused? Who's confused? Okay, Hannah, help me out with the second one. Or the third one. Let's see if we can get you on confused. And if we can't, we'll go from there, okay? So help me out with the third one. Good, we can't simplify anything, so then what? Good. Yeah, and it has a 1 on it, right, technically? And then what else do you have there? Good. So what does negative 3 to the 5th power mean? Good. It does not mean negative 3 times 5. It means you're listing it out and multiplying that way, right? And like you said, what do we do with an exponent to an exponent? What do you do with an exponent to an exponent? Good. Remember, if you get confused, list it out. It doesn't hurt you to list it out. It might take a little bit of time, but that's about it. So what's negative 3 times negative 3 times negative 3 times negative 3 times negative 3? Negative 243. And then we multiply, so 1 times 5 is 5. G to the 40th. Hannah, did that make more sense? Are you sure? Don't lie to me.
I'm just like, I usually like, they make, like, I don't know, making examples confuses me more than actually does the problem.
Making examples.
Yeah, like these are too many examples to write down.
Yeah.
You need more examples. There's so many different ways to look at these problems.
Like, I'd rather just solve the problem
Then have all the steps, the thing.
and then if you have to,
You mean you don't like all the steps that I'm writing down? Is that what you're saying?
yeah, 'cause then I get confused.
Well, and like I said, on your homework, you don't have to do that. This is just for your notes. So, Kelly, Etheridge, help me out with this number 4. What am I going to do here? Okay, can we simplify anything first? You will do that too eventually, but can we simplify anything first? Guys, please pay attention. Is there anything that we can simplify first, Kelly? Do we have anything in both numerator and denominator that can be simplified? Which one? The z's. When we divide, what do we do with the exponents? We subtract them. So I have negative 6x, z to the second minus 2 on top, and then I have 5y to the third, all squared. So 2 minus 2 is? What do we know anything to the 0 power is? So do we even need that z in there anymore? Anything to the 0 power is 1, so this is where we're left. Now you can do something with that too, Kelly. So what am I going to do with that too, Kelly? I can wait. So when you say we distribute, talk about that. What do you mean we're doing with the square and the negative 6? What are we going to do with that?
We're multiplying 2 times.
Are we doing 2 times negative 6, guys? Is that what that's saying? No, that's saying negative 6 times negative 6, which is different than negative 6 times 2. It's saying put the exponent on the 6, which means list it out twice. So we put the exponent on there, Kelly. So it's important that you guys realize that listing it out does not hurt you. I really think that some of you guys are going to need to only list it out and not even do the rules to start off. Eventually drift towards that. But this is what we have. So we have negative 6, Jenny. Yeah, I know. It's not that cold in here. It feels good. Okay, negative 6 times negative 6 is 36. 1 times 2 is 2. 5 times 5, you're not doing 5 squared. 5 times 2, you're doing 5 times 5. And then I have y to the 6. Do you guys have questions there? Okay, go ahead and get that copied down. What I'm going to do instead of doing the